now that we have us a model, let's see if we can figure out a way to explain it. And I'll admit right at the beginning that this is going to be a lot easier to do if we have a picture. But I want to talk about the kind of wording we might use before we do the picture, because you can't just rely on a picture. You should know the right kind of words to use. So let's look at our summary. There's the numbers. These are the numbers that we've got to be able to explain. And I want you to be aware of some temptations that you'll want to use, but these are not good ways to talk about it. You can't just say that as age increases, brain function drops by 0.066. That is the true coefficient for age, but you have an age times hours value here, which means it would be equally wrong to say that about hours. And you can't just fix that by, okay, age and hours. Now let's talk about age and hours together. You've put periods here. That means these are separate sentences. So as age increases, brain function drops by 0.066. That's not true. It depends on the level of hours. It would be true at an hours of 0, but it's not always true. And so there's clever ways to try to combine it into one sentence so that it's not like you have a false sentence followed by a sentence that fixes it. But read this. As age increases, brain function drops by this much and drops by another this amount per hours. That sounds good, but it's a confusing sentence. Do you mean it drops by this much as a stable amount if there's hours that increase? Is it hours that are increasing or staying stable? This is really a tough sentence for a client to try to understand. Even though this is the same sentence simplified, and it's actually mathematically correct. It's not bad because it's false. It's a true statement. It's bad because it doesn't help explain what's going on. This is going to be confusing for a client. So then sometimes students will flip the other way. Instead of giving you a confusing sentence, let me really simplify it. Age goes up, brain function goes down. Okay, but you can explain a lot more than that. There's a lot of different ways that it could drop. Drop quickly, drop uniformly. I mean, what's going on there? So how do we find that middle ground? Not so simple that we haven't clearly explained what's going on, but not so complex you can't understand it. So here's some good explanations, and then in the next video we'll talk about how could you draw a picture so that this was more clear. So let's start by actually looking at what the prediction equation is. It's brain function, and it's in red. That makes it look scary. We have brain function equals, there's our intercept, there's our coefficient on age, coefficient on hours, and this here, the age times hours interaction, is literally just the coefficient times age times hours. So if I want to start by explaining age, then I'm going to simplify this equation in terms of age. These are the same equation. If you don't believe me, pause the video and work through the math. So here I have an intercept. If I'm explaining age, none of these values are going to be of importance to that explanation. This is just the intercept. It's a shift in what age does. Here is the effect of age on brain function. That's my slope. And yes, the slope has hours trapped in there, but this is the piece that's important if I want to try to explain the effect of age on brain function. So let's start by explaining age, to explain age. And what do? I start with hours, which seems ironic. I thought we were explaining age. Well, we are, but I'm going to say if hours equals 0. Now that I have fixed hours, it's easy to talk about the slope. If I put a 0 in right here, then whatever times 0, this becomes 0, and I'm only left with this. So for each increase in age, brain function drops by 0.06635. But then if I increase the number of hours, the brain function drops by more per year of age. How did I get this? I put a 50 right in here. Since we're talking hours equals 25, 25 goes in there, work the equation out, 0.6814. And then I can do the same thing at 50, a larger drop. How'd I get that? I put 50 into the slope for age, and there it is. So this helps me see that as the age increases, brain function drops, but as hours increases, that drop becomes more dramatic. But so far, I've only explained age. For hours, I would solve this equation for hours. Here's the pieces of that equation that don't include hours, and so they're really not of interest when I'm explaining the effect of hours. There's the slope of hours, which does have age in it. So I'm going to start by setting my age. I've used 20, 50, and 80. How did I get that? Well, I just looked at age and hours. Age goes 20 to 80. Hours went 0 to 50. So I picked 3. How many should you pick? Well, that's kind of up to you. Some people like using 5. Some people like using 6. When we draw the picture, you'll see why that might matter. But I just went ahead and solved it. Now I've got the 0.47, the 1.2, and the 1.95 for each of those levels of age. And you can see what's happening. As you increase the hours, your brain function drops. But the older you are, the more your brain function drops. So that's a decent explanation. I think a client reading this and looking at the picture that we're going to do in a second, they'd be like, okay, I can kind of see what's going on. But there are ways to explain it that are not quite as pedantic, and I think you could argue actually help you understand it a little more. Age increases, brain function drops. The more hours, the greater that drop. Same for hours, which, take a second to appreciate that. If you look up here at the coefficients, it looks like if you work more hours, your brain function increases. That's not true because this term right here is going to overwhelm, and this term right here is going to overwhelm whatever positive effect there might have been. So working more hours is still going to drop your brain function because of that interaction term being so strong. And check this sentence out. Basically, increasing both make your brain function drop faster. That's meaningful, and it shows that you're really thinking about what's going on. Now, we've gone through the wording because I want you to think about that before you just rely on the picture. But I think you'll be able to see the picture is going to make this a lot more clear. So let's go on to the next video and see if we can draw what this is doing.